So next we have two speakers. I'm going to share my screen. So they are Krish and Mikhil. They are 8th graders at the Harker Middle School, and they will be talking about their application called Ceye, Assisting the Blind.
I'm Krish, and this is my partner, Mikhil. Our app is Ceye, an app that assists the blind. So what is our project? Well, our project, Ceye, was made to assist the visually impaired with currency differentiation. What was our motivation for this problem? Well, according to the WHO, over 2.2 billion people have a visual impairment across the world. Many of these individuals are challenged with recognizing currency bills on a day-to-day basis. The two of us also happen to suffer from visual impairment, which was our main motivation for solving this problem. Current solutions, such as Cash Reader, do not factor in realistic situations such as bad lighting and angles of photos. So what is our solution? Well, our solution is to create an app, as you can see from the two pictures on the left, that is integrated with accessibility features and allows users to take a picture of a note or upload an existing picture from their photo library. Then the app reads the response back to the user through VoiceOver. Our app is powered by an AI and neural network. So the first part of creating an AI is obviously to gather the data set. So that's what we did. We created a data set consisting of 1.8 thousand images of dollar bills. 95% of the data set was created by taking pictures of various dollar bills in 3 categories. 1, close up, 2, with background, and 3, rotated, with 600 images of each. 5% of the images were downloaded from the internet and also by hand. So this part of the project took 2 to 3 months and was definitely the most tedious part of the project.
To make our AI, we used AIClub's Navigator to invoke TensorFlow's MobileNet V2 model, a convolutional neural network that's 53 layers deep. We created our AI model in 2 different ways. We made a single layer AI, which combined the 3 image categories into a singular dataset. And we also made a 2-layer AI, which had a selector AI to identify the image category, and then picked a specialized AI depending on the image category to make the final prediction. We also built an iOS app and integrated the AI model into the app. The diagram on the slide is a quick diagram of our AI model and how it got integrated into our app. We also experimented with the epochs and learning rate hyperparameters in order to get maximum accuracies for our AI. There's a diagram on the slide for each one of our AIs and all of the experiments that we did. Each of our AIs got best case accuracies of 98 to 100%. We wrote Python code to compare our single layer and 2-layer AIs. We used 20% of our data set for testing these AIs. The code first predicts using the AI, and then the results are compared with the folder names of each image, as this is how we checked if the AI predicted correctly or not. In that same code, we also generated confusion matrices for both AIs. For our single level AI, we had the greatest confusion in identifying 50 front, and it often confused it for 20 front. And for our 2-level AI, it had the greatest confusion in identifying 5 back, and the confusion was spread across different types of dollar bills. Our learnings from making these AIs were that we learned that training accuracy is usually very high, while validation accuracy is much lower. This is proven because our training accuracy was over 98% for every AI, but our validation accuracy was only 83% for a single level and 71% for 2-level. We also learned that each image category must consist of an equal number of images for the AI to not develop bias. Now, my partner is going to do a demo of our app.
All right, so right here, as you can see, I've pulled up a demo of our app on a simulator. And so if you look towards the bottom of the app, you can see 3 tabs. Home is in the middle. To the left, we have Take Photo, and to the right, we have Image Upload. So for the purpose of this demonstration, I will be clicking on Image Upload and taking a photo from my photo library instead of taking a photo in real time. So let's click on Image Upload. Now my photo library is open, which is already stocked with a few pictures. For example, let's click on this one. Now, this is a combination of two categories. First, it is with background because it is taken from a farther distance, and two, it is rotated because it is shifted to the side. And this is a $20 bill. So hopefully, as soon as I click choose, the AI will predict that it is in fact the front of a $20 bill.
This is the front of a $20 bill.
So as you can see from the text on the bottom and the voiceover, it says that this is the front of a $20 bill, and it has correctly predicted what it is. And now back to my partner to wrap up the slides.
In the future, we hope to increase our data set with different types of dollar bills and also expand into currencies of other nations. As of right now, our app isn't available on the App Store or the Play Store. So we need to make our app compatible with Android and then deploy our app on both the App Store and the Play Store. Thank you so much for listening.
Thank you, Krish and Mikhil. There's quite a few questions. You can return the host privilege to me. I'll ask the questions also. So first question is, how long did it take for you guys to collect the data? You have an amazing collection of data.
Right, I can answer that. So we gathered our data by taking hand pictures, as I mentioned. And this took place after school on many days or for hours on the weekends. So it took around 3 to 4 months to gather all those 1,800 images.
Wonderful. And then similar question, you have a lot of experiments. How long did it take you to run those?
I think Mikhil can answer that because he was the one who ran most of them on his computer.
Yeah, so for every single experiment, it took there was about 1 to 2 minutes in between every experiment just to change the hyperparameters. And then each experiment took 15 to 20 minutes for some of them, and then the longer ones would take around 30 minutes. So I'd say it was around 30 to 40 hours.
Makes sense. So do you think that a visually impaired person can navigate the phone app and use it?
Yes, because like I mentioned before, we have integrated Apple's accessibility features with it, which include voiceover and text enlargement. So if you happen to be not fully blind and rather just have some degree of visual impairment, you can use Apple settings to make our text larger, and therefore you might be able to read it better. Or if you're completely blind, we have voiceover. So if you click a button, then it'll read it out loud. So as soon as you find your way to the buttons, it'll be easily accessible to use the whole app.
Nice. And then the final question is, given that you've created such an amazing data set, do you have plans to publish it somewhere, like on Kaggle or in a GitHub repository or something like that, so that other people can also benefit from your data?
Right. So I think we were never thinking about that, but I guess that is a good idea, because when we came up with this project, we searched on Kaggle and then there were no data sets. So maybe we can help somebody else with their project by publishing our data on Kaggle.
Very nice. Okay. Thank you very much, Krish and Mikhil. Wonderful presentation.
Thank you.